Hey everyone. Hope you're all doing alright today. Alright, O-Level Physics, Lesson 2. We're on light, refraction, and lenses. Light travels in straight lines through a uniform medium and can be represented by rays with arrows. Reflection obeys angle of incidence equals angle of reflection, with both angles measured from the normal. A plane mirror forms a virtual upright, laterally inverted image the same size as the object and apparently the same distance behind the mirror. Virtual rays only appear to meet. Refraction is caused by a speed change at a boundary. The refractive index n equals sin I over sin r for light entering from air, and also n equals speed in vacuum, speed in medium. Entering glass from air, light slows and bends toward the normal, leaving glass, it speeds and bends away. Frequency and color remain unchanged, but wavelength changes because V equals F lambda. Total internal reflection occurs only when light travels from a higher refractive index medium toward a lower one and incidence exceeds the critical angle C. At C, the refracted ray travels along the boundary. For a medium to air, sin C equals 1, all over n. Optical fibers guide pulses by repeated total internal reflection, enabling low-loss, high-bandwidth communication and internal viewing in endoscopes. A thin converging lens bends parallel rays toward its principal focus. Draw two reliable rays from the top of the object, one parallel to the principal axis refracts through the far focus, and one through the optical center continues straight. Their intersection locates a real image. An object beyond focal length forms a real inverted image, inside focal length it forms a virtual upright magnified image. The lens equation is 1, all over f equals 1, all over u plus 1v for suitable real object conventions, and magnification equals image height, object height equals v, all over u in magnitude. If u equals 30 cm and f equals 10 cm, 1, all over v equals 1, all over 10 1, all over 30 equals 1, all over 15, so v equals 15 cm. Magnification is 15 all over 30 equals 0.5, giving an inverted image half the object height. A camera uses a converging lens to form a real image on a sensor, while the eye forms a real image on the retina and focuses by changing lens shape. A magnifying glass places the object inside focal length to form a virtual magnified image. In ray diagrams, use a ruler, label F and the axis, and distinguish where actual rays meet from backward extensions. Draw the normal and label angles first. For lenses, mark both focal points and use two standard rays from one object point. Calculate only after predicting image type, orientation, and approximate position. For glass with n equals 1.50, sin C equals 1, all over 1.50 equals 0.667, so C is about 42 degrees. Incidence of 50 degrees inside glass gives total internal reflection at a glass air boundary. Do not measure angles from the boundary, claim light frequency changes, use total internal reflection from air into glass, or draw a real image where backward ray extensions meet. Practice. Light enters glass with I equals 45 degrees and R equals 28 degrees. Calculate n. Answer, n equals sin 45, all over sin 28, approximately 1.51. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. A converging lens has f equals 12 cm and object distance 36 cm. Find image distance. Answer, 1, all over v equals 1, all over 12 1, all over 36 equals 1, all over 18, so v equals 18 cm. Image is real and inverted. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. That's all for light, refraction and lenses for now. Coming up next in O-Level Physics, sound and the electromagnetic spectrum. Take care, and I'll see you in the next one.